Welcome back to College Algebra, and we're doing our series on the basics, which is where we describe how the numbers work that we're going to be using throughout College Algebra. In particular, we're in a series on decimals, and today we're talking about division with decimals. So we want to learn how to divide using decimals. Let's start with a problem, as we often do. The problem is going to be 0.8 divided by 0.2, and the question is what is this answer? Well, there's several ways of thinking about this answer. The way I would think about it is that we have 8/10 and 2/10, and so we have to ask, how does 8/10 get split up into groups of 2/10, or how many 2/10 groups does it take to create 8/10? Because remember, division at its core can be thought of as a process of grouping. I'll say that that's not the only way to think about division, but it's a very useful one, and it's going to be very useful for us today. So I'm going to start with kind of a visualization, and the visualization is that I might have this image right here that shows my 8/10, and so you'll see if this green block was one green block that we've had throughout our problems. Then I split it up into 10 pieces, and I have 8 purple strips here, each purple strip representing 1/8. Now, if I come over here and think about this green block as being our 0.2 green block, then this 0.2, I've split this green block up into 10 pieces, and I now have 2 of those. And the question is, how many of these 0.2 blocks, how many 0.2 pieces make up the 0.8 piece? So how many of these 0.2 pieces make up the 0.8 piece? And if I look closely, I'll see that I can put 2 more, and 2 more. So it seems like I need 1, 2, 3, 4 different groups, and I could visualize them like this, as then there's a group of 2, there's a group of 2, there's a group of 2, and there's a group of 2, and the answer is I need 4 groups. Groups size 0.2. Another way of thinking about this would be to, let me represent this one more time, just using our actual physical blocks. And so I'm going to bring out a stick here, and I'm going to say this stick is actually 1. This stick is equal to just 1 object. And so what does 0.8 look like? Well, 0.8 would be a stick that has 3 green blocks, that has 8 green blocks on it. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So these 8 green blocks are making up my 1 stick. And so if this is 1, then this is 0.8, and then if I want to create 0.2, I create another stick that has 2 blocks on it. And the question is, how many of these green blocks, of these collections of green blocks, does it take to make up that collection? And you see the answer is 1, 2, 3, 4. So I needed 4 collections of those 2 green blocks to make that up. Now, what I want us to realize for today, because we don't want to have to pull out blocks or draw pictures every time we start the problem, we're going to think, how could we have visualized or thought about this problem differently? Well, the answer is, what if we visualized this block, instead of being a block of 1, what if this block was a block of 10? Then this block would be 1, 2, 3, 4, 5, 6, 7, 8 blocks, and this block would be 1, 2 blocks. And what you'll notice is dividing 2/10 into 8/10 is the same as taking 2 and putting it into the number 8. All we've done is change our perspective. We've just shifted what we're thinking of as the unit. Instead of the unit being whole numbers, they're now tenths. But the division was actually the same. And this brings us to our real basic idea. And the basic idea is that 0.8 divided by 0.2, let me put my 0 so it looks like, is the same as 8 divided by 2. So 0.8 divided by 0.2 is the same as 8 divided by 2. So well, that's nice. That means that this decimal place was really just kind of a distraction more than anything else. The problem is actually a very simple problem that we could have solved at the beginning. This is going to bring us to our basic principle that we're going to follow throughout the class today, and it's that when dividing, we simply move the decimal point. So we move the decimal point of both numbers to the right the same number of places until you're dividing by a whole number. And so what would that mean in this problem? In this problem, that would mean I took this decimal point and this decimal point, I moved them both to the right one spot until they were both the same numbers, and then until this number that I'm dividing by was a whole number. Life becomes a lot easier if this number on the right that you're dividing by is a whole number. So that's going to be our basic principle, and we'll come back and talk about why that principle should be true in just a minute. But first, let's work on a problem and see how that problem plays out if we think about this principle. So we got 2.75 divided by 0.25. If I want to divide these, then I want to move both numbers. I want to move the decimal places of both numbers until they become a whole number. So I'm going to take this decimal point and I'm going to move this one to the right 2 spots. Notice I moved it to the right 2, and so that means this one I'm going to move to the right 2 also. So that means my division problem now becomes 275 divided by 25. What's important is that I should get the same answer. I should get the same answer no matter which of these two problems I work. And the problem without the decimals is the problem that's the easier one for us to solve. So as I come to solve it, I do it using my traditional division, where I'll put the 275 inside the little house, 25 outside. I know it's not a house, but it's fun to think of it like that. And then I look and say, okay, 25 goes into 27. I always like to make a little arrow to acknowledge where I'm starting at. 25 goes into 27 one time. 1 times 25 is 25. We're left over with 2. Bring down the 5. And now up I get one more. 1 times 25 is 25 and 0. So it looks like my answer is 11. So it looked like I had 11 25s, making this number 275. So the answer to both, 275 divided by 25 is 11, and the answer to 2.75 divided by 0.25 equals 11. Okay, let's come back to that first question we had and ask ourselves the ever so important question of why do we get the same answers when we do both of these? And I'll give you one more reason why we should believe that this process works. As you can remember from the last time we talked about multiplication, we want to have two things. First, we want to have a rule that we can apply, but we don't want to become so dependent upon the rule that we only remember it and we don't remember why it's true. Because rules that we memorize might disappear. They're fleeting, they leave us. But understanding stays with us. So if you truly understand why decimals work the way they do, then the rule itself becomes obvious. And you don't have to memorize it, you can just remember how the decimals interact or work with each other. So coming back to that problem we had earlier of 0.8 divided by 0.2, I want to think about this problem instead in fraction form. So if we think about this as a fraction, what you remember is division is the same as writing it as a fraction. When you see this fraction, 0.8 over 0.2, you should think 0.8 divided by 0.2. So these actually are the exact same thing, just written with simpler notation. But what you will remember about fractions is we can simplify them by multiplying or dividing both the top and the bottom by the same number. So for example, if you have a number, say 3/4, you can multiply the top by 2 and multiply the bottom by 2 and get a new number, 6/8, and the new fraction is actually the same as the original fraction. So 6/8 and 3/4 are the same fraction, just written differently. So you can take any fraction and multiply them by the same number and come up with the same fraction. Well, this works wonderful for decimals, because now if I want to move this decimal to the right, I can multiply this by 10 and multiply this by 10. And so now, if I multiply both the top and the bottom by 10, I haven't changed the fraction. We've actually got the same number. And notice, what is 0.8 times 10? Well, remember, when we think about decimals, we think about multiplying by tens, move the decimal points to the right or left. And so this 0.8 times 10 gives us the number 8, and this 0.2 divided by 10 gives us the number 2. And so 0.8 over 0.2 is the same as 8/2, or 8 divided by 2. So that's why when we divide, we move the decimal point the same number on both parts. Okay, now let's look at one more problem. In this one, we have 0.2 divided by 0.008, and let's see if we can think our way through how to solve this problem. Well, when we do division, we always put the inside part right here, and then we put the outside part over here. But you remember, we don't want to divide by a decimal. What we instead want to do is divide by a whole number. And so the question is, we need to move the decimal over, and I'm going to look at this 0.008, or the 0.008, to determine how many places to move my decimal. It's not so important that this number is a decimal. It's important that the number outside the division, the number we're dividing by, doesn't have decimals. It makes our life a lot easier, simpler to work with. So I'm going to move this 1, 2, 3 places. And then notice that I have to move over here 1, 2, 3 places. Now, you've probably seen this before, but recall, when I move additional places, that means I have to add zeros into these additional places. There are always zeros present, right? 0.2 is the same as 0.200. So as I move these decimal places to the right, I get extra zeros. So now I'm dividing the number 8 by the number 200, or dividing, sorry, I said that backwards. I'm dividing number 200 by the number 8. I'm going to go ahead and put my decimal place up here in my answer, and then go about dividing just the way I would have. So look at 8. 8 goes into 20 2 times, and that leaves me 16. I get a remainder of 4. I bring down my 0. 8 goes into 40 5 times. 8 times 5 is 40. I have no remainder, and so my answer is 25, and there was no decimal point. Notice that the problem that I solved was the exact same as the problem of 8 divided by 200. So I moved the decimal point over 3 times, 1, 2, 3, and then I moved 1, 2, 3, and I got an equivalent problem that had no decimals in it. Now, as we normally do, let's end by trying a few problems on our own and seeing if we can get the correct answers. So pause your device for just a few moments and see if you can work out the solutions to these two problems. Okay, we're back. Thank you for trying both of those problems, and let's look and see what we get for our answer. Let's do problem A first. I'm going to put the 8.16 inside the division and the 0.4 on the outside, and ask myself, well, how many decimal places do I want to move it? I want to move this 1 decimal place, and so it means I'm going to put my decimal place right here, right above, right between the 1 and the 6. So I move both of them 1 decimal place, and now I start trying to divide. Let's see, 4 goes into 8, it looks like 2 times. 2 times 4 is 0. I bring down a 1. 4 does not go into 1, so I'm going to put a 0 here, and I'm going to bring down my 6. 4 goes into 16 4 times, and 4 times 4 is 16, and now I have no remainder. So it looks like my answer is 20.4. That was fantastic. Let's try our next problem and see how it works. This time I'm going to put the 0.015 inside my fraction, or inside my division and put the 0.75 on the outside of my division. I'm going to look again and say how many places do I need to move over my decimal. I need to move it over 2 places. So I'm going to move this one over 2 places as well and put the decimal right here. Now, as I look through, I realize that, well, 75 doesn't go into 0 or 1. 75 doesn't even go into 15. So I need to add another 0 on here. 75 does go into 150. It goes into 150 2 times. So 2 times 75 is 150, and so I get a remainder of 0. So it looks like my answer for this problem is 0.02. And those are our solutions. Thank you for following through these lessons on decimals. Let me just say there are a lot of really great resources online. There are a lot of other very good videos to watch where people talk about decimals. If you find yourself struggling with these, please feel free to contact me, and I'll point you towards other resources, or we can work together on finding them. Thank you very much, and I'll see you next time.